Ask a model a question about your company's internal documents, and it does one of two things. It refuses, or worse, it confidently makes something up. It was never trained on your data. The fix is retrieval augmented generation, and it is the most tested pattern in these interviews. The idea sounds almost too simple. Before the model answers, go find the relevant text and paste it into the prompt. The model reads it and answers from it with a citation. Everyone can say that sentence. The interview is about the parts underneath, how you find the right text, fast, at scale, and how each part fails. Let's build it from the ground up. First, when is retrieval the right tool? You have 3 ways to give a model knowledge, and interviewers want you to know the difference. Fine-tuning. You further train the model on your data. This is the right tool to change how the model behaves or writes, its tone, its format. It is the wrong tool for facts that change, because retraining every time a document updates is absurd. Long context. Paste everything into the prompt. Perfect when the material is small or a one-off, but it does not scale. A huge context is slow, expensive, and the model's attention thins out across it. Retrieval. Keep your knowledge in a searchable store and fetch only the few relevant pieces per question. This is the tool when knowledge is large, changes often, and you need to cite a source. So, a rule of thumb. Fine-tune for behavior. Long context for small. Retrieval for knowledge at scale. And real systems often combine them. Retrieval starts before any question arrives by preparing your documents. And the first real decision is chunking. You cannot embed a 100-page manual as one unit. Retrieval would hand back the whole book. So you split documents into chunks, passages small enough to be precise, large enough to stand alone. There are a few ways to cut. Fixed size is the naive one, every so many characters. Recursive splitting respects structure first, paragraphs and sentences before falling back to size. Semantic chunking cuts where the meaning shifts. And layout-aware chunking follows headings and tables, so a chunk is a real section. And there is a real tension in the chunk size. Too small, and a chunk loses the context that made it meaningful. Too large, and the one useful sentence is diluted by noise, and you pay for the wasted tokens in every prompt. There is no universal answer. Smaller chunks for looking up facts, larger for passages that carry an argument. It is a dial you tune for your corpus, with a little overlap so you never split a thought clean in half. Now, each chunk becomes a vector through an embedding model. An embedding model reads text and outputs a list of numbers, a point in a high-dimensional space, placed so that text with similar meaning lands nearby. The word dog and the word puppy end up close. A sentence about a refund policy sits near other refund sentences and far from a recipe. This is the quiet magic of the whole system. Meaning becomes geometry. And once meaning is geometry, finding relevant text becomes finding nearby points. How do we measure nearby? The standard is cosine similarity, the angle between two vectors, ignoring their length, or a dot product, which gives the same ranking when the vectors are normalized. Small angle, similar meaning. So, the shape of it. Your documents are now a cloud of points, each one a chunk, positioned by meaning. When a question comes in, we turn it into a point too, and look at its neighbors. Here is retrieval, the moment the system earns its name. A question arrives. We embed it with the same model, so it becomes a point in the very same space as our chunks. Then we ask a geometric question. Which chunks are closest to this query? The nearest neighbors are the most relevant passages. We take the top few, the top K, and those become our candidates. That is the core of retrieval. Embed the query, find its neighbors, return them. But a scaling problem hides here. With millions of chunks, comparing the query to every single point is too slow. So we do not. We use an approximate nearest neighbor index. Instead of checking everything, one kind of index hops through a graph, always stepping toward closer points. Another clusters the vectors and searches only the nearest clusters. Both give up a tiny bit of accuracy in exchange for an enormous speed up. And you can tune that trade-off. This index is what makes retrieval feel instant, even over millions of documents. The top candidates from that search are good, but not yet in the right order. So strong systems add a second stage, re-ranking. Think of a coarse sieve, then a fine one. The first stage, the vector search, was fast because it compared the query and each chunk separately as two independent points. Quick, but it never looked at them together. The re-ranker does. It takes the query and one candidate passage and reads them as a pair, letting every word of the question attend to every word of the passage. That is far more accurate at judging true relevance. It is also far more expensive, which is exactly why you do not run it on millions of chunks. You run it only on the handful the first stage shortlisted. Retrieve wide and cheap. Re-rank narrow and precise. Keep the best few. It is often the single biggest quality lever in the whole pipeline. We have the best few passages. The last step is assembly, and then the failures. Assembly is straightforward. Paste the top passages into the prompt, each tagged with a source number, and tell the model to answer using them and cite the number it used. Done well, every claim in the answer links back to a real passage a human can check. Now the three ways this breaks, because an interviewer will ask. 1. The relevant passage exists in your store, but retrieval never surfaced it. A retrieval miss, and everything downstream is guessing. 2. The passage was retrieved and handed to the model, but the model leaned on its own memory and ignored it, sometimes inventing an answer instead. And 3. The answer is correct, but the citation points at the wrong passage, which destroys trust the moment someone checks. Each failure lives in a different part of the pipeline, and each has a different fix. Naming which one you're seeing is the diagnosis an interviewer is listening for. Retrieval augmented generation, part by part. Chunk your documents with care. Embed them into a space where meaning is distance. Retrieve the nearest neighbors with an approximate index. Re-rank the shortlist for precision, and assemble a cited prompt the model answers from. And know when not to reach for it. If the knowledge fits in the prompt, or the problem is behavior rather than facts, retrieval only adds complexity. Your practice follow-up. A chunk says, "It qualifies," where "it" is a policy named only in the previous chunk. Which failure mode bites, and how would you fix your chunking?